Our next lesson is the slope criteria for parallel lines and writing equations of lines. In this lesson, we'll hit 1, CCRSM standard, prove the slope criteria for parallel lines, and use it to solve geometric properties. For example, find the equation of a line parallel or perpendicular to a given line that passes through a given point. Let's get started. We are in lesson 8 of your student materials, and we'll start down here with example 2. And the question is, what is the relationship between the coplanar lines, between coplanar lines that are perpendicular to the same line? So I want you to sketch this graph in your student materials. All right, what this is line AB is perpendicular to both line AC and line BD. Okay, so I'm given that segment AB is perpendicular to segment AC, and segment AB is also perpendicular to segment BD. And I want to prove that based on this and this alone, that I know that AC must be parallel to segment BD. That's my goal. Now, I could go back and use similar triangles like I did for perpendicular, but I figure I already have proved perpendicular, and so I can use the slope criteria for perpendicularity and make this pretty easy for myself. So, because segment AB is perpendicular to segment AC, then I know that the slopes will be negative reciprocals of each other. So the slope of AC is equal to -1 divided by whatever the slope of AB is. That's also true for AB and BD. That because AB and BD are perpendicular, then the slope of segment BD must be -1 divided by the slope of AB. Next, we'll notice that the slope of segment AC and the slope for segment BD are both equal -1 over the slope of AB. So they are equal. So that is the slope criteria for parallel lines. If two lines are parallel, then they will have the same slope. Their slopes will be equal. So now let's use that. That's our first part of the standard. Let's use that in some equations. So we'll jump down here to exercise 2, and we're given the point -3, 6, and a line y equals 2x minus 8. Now this is in the form y equals mx plus b, which you've seen before in Algebra 1 and in Math 8, and that's about it. In those 2 years, you've seen this equation before. Remember that m is the slope of the line, the coefficient of x. If it's in this form, the number in front of x is the slope, okay, which we defined slope in the previous video. B is the y-intercept, meaning that's where it intersects the y-axis. Okay? Now, in A, it asks what's the slope of this line? Well, it's the number in front of x. The slope is 2. I'll write m equals 2. Now, it's not 2x. It's a very common mistake made by students, but it's just 2 is the slope, not 2x. B, what is the slope of any line parallel to the given line? Well, I just proved that it would have the same slope. So it'd be 2 again. C says write an equation of the line through the point and parallel to the line. Okay, now this hits exactly what the standard is talking about. Is given a slope and a point and an equation of a line, find the line parallel to it. All right, I already have the slope that I want, and I have a point for it to go through. So what I'm going to do is to use the y equals mx plus b format and solve for my new y-intercept. So I'm given y is equal to 2x plus b, but I don't know what b is yet for this point. Okay, it will not be -8 because this, I'm guessing, does not go through that point. So if I plug x into x and y into y, then I have 6 is equal to 2x, not 2x, 2 times negative 3 plus b. And now I'm simply using some algebra to solve for b. 6 is equal to 2 times negative 3 is negative 6 plus b. Let me go up here so I have more space. Again, 6 is equal to negative 6 plus b. I will add 6 to both sides, and I find that b is equal to 12. Okay, so now I just simply plug this back into the original equation, and I get y is equal to 2x from my slope of line parallel plus b, which is 12. And this is the equation of a line through the given point parallel to the line. D, what is the slope of any line perpendicular to the given line? Well, perpendicular, in our last lesson, we learned that I have a slope that's a negative reciprocal. So if I take the fraction 2 over 1 and I flip it over and change the sign, I would get negative 1/2. So the slope of a line perpendicular to this line would have a slope of 1/2. Now, could we write an equation of a line that went through the point with that's perpendicular? And the answer is yes. I'm not asked to do that, so I won't do it here, but we could do that, go from a slope and a point, and find, either parallel or perpendicular. Number 3 is a similar problem. Write an equation of the line through the point 0, negative 7, parallel to the line y is equal to 1/2 x plus 5. A, what is the slope of any line parallel to the given line? Well, it's equal to 1/2. That's the slope of this line, is the number in front of x. It's 1/2. And the reason is parallel lines have the same slope, as we proved earlier in this video. B, write an equation of a line through the point and parallel to the line. So again, I have a slope and I have a point. So I'll start with y is equal to mx plus b. I will plug, 1/2 in for the slope. I will plug this y value into y and the x value in for x, and I get negative 7 is equal to 1/2 times 0 plus b. And 1/2 times 0 is 0 plus b. If I take this up here for more space, plus 0 is just itself, and so I get b is equal to negative 7. So from the slope, I have m is 1/2, so I have y is equal to 1/2 x, and the y-intercept is negative 7. So this is the equation of the line parallel to the given line that goes through the point 0, negative 7. C, if a line is perpendicular to y equals 1/2 x plus 5, that was the given line, will it be perpendicular to x minus 2y equals 14? Now, please notice that this equation is not in the same format as y is equal to mx plus b. It's a different format, okay? So you can't look at the number in front of x and say, well, in front of x is a 1, or, the 1 would be here if I wrote it there. So the slope is 1. That's not true. It is not in the same format, okay? This is called standard form. I'm not sure if you've seen that before last year in Algebra 1, but it's called a standard form of a line, and it has different properties about it, okay? But I can take this form and convert it into the y equals mx plus b format to then see what the slope is going to be. So to do that, you solve the equation for y. So y is by itself in this slope-intercept form. And so I'm going to take this equation right here and solve for y. So I'll do that by first adding 2y to both sides. And I get x is equal to 14 plus 2y. I will subtract 14 from both sides. So I've now isolated 2y, so I have x minus 14 is equal to 2y. Now if I divide both sides by 2, every term by 2, then I have x over 2 minus 7 is equal to y. And I'll flip that around using the symmetric property of equality. And I get y is equal to x over 2 can also be written as 1/2 x. So it's really easy for me to see what the slope is, minus 7. So now it is in this form. And because it's in that form, I can now read off the slope as the number in front of x, and so I get 1/2. Okay, back to the question. The question said, if a line is perpendicular to y equals 1/2 x plus 5, will it be perpendicular to the line y is equal to 1/2 x minus 7? And the answer is yes, because the two given lines have the same slope, and any line perpendicular to one of them will be perpendicular to both of them. And that's it. This video is about the slope criteria for parallel lines. If the lines are parallel, they have the exact same slope. And we did some practice with writing equations of lines. We'll do a lot more practice during class, but this is it for now. Thank you for watching.